Hello, welcome to Future Tailors, where white balance is a thing of the past. In this video I will share some tricks that I figured out on how to print better bottoms for your 3D prints and avoid this kind of unwanted artifacts, and how to print better. So the solution relies on a trick which I figured out a couple of days ago, and I think the results are incredible. So first let's look at some prints and what I mean with better bottoms on the print plate. For the past couple of years I've had an Ultimaker 2 at my disposal, and of course in the beginning I didn't really know how to make use of this machine, but then you start learning the software, you learn how to better design for how the machine works. So designs which can be printed from the bottom to the top and obtain the best results. And of course you play with a lot of different materials, and FDM is not the most merciful technology when it comes to printing in high quality, but nonetheless I've achieved some pretty incredible results in with a lot of cases and parts which I printed. So one of the most successful ones that I have produced is this toy Otto, which I presented at FITC conference this year in Amsterdam, and it was quite a challenge, but in the end I think the final result, what people can have in their hands, is quite nice. It feels like a really solid widget, no matter the technique it's being printed with. And of course this thing is full of electronics, it's got magnets to keep it together, and everything is set nicely. You can see that the details are pretty good, but the bottoms, they are rough to say the least. When I use cheaper materials, well, one of the things which I never really liked was printing on stick glue. And a lot of people had that blue tape, which gives rough bottoms. What I really liked was printing on the bare glass. Printing on glass produces a really nice finish. Of course, when you have support material, the rounded edges, they don't come off really well, but the part, once the print bed is cool, you can remove them easily, and this is with cheaper materials. A few months ago I switched to what I believe is the best filament which I've used up till today, and it's rigid ink. So you can look them up online. I will put a link in the description of the video. What I really like about this material is that when it prints, when it starts printing, as soon as it's extruded, it starts expanding. So the layers stick to one another really nicely. But I had a problem with this one, and consider a print like this, which takes about 8 hours to finish, because I print at almost the highest resolution which I can pull off of an Ultimaker 2. The real issue that I had is that no matter how long I left the print bed to cool, the material is so good and it expands so well that it won't come off the print bed. And to remove these parts, I have literally ripped through the layers. Some of them a little better, some of them worse. You've seen this one completely cracked. So I had to resort to looking on forums, and what people were saying around the web was, well, your solution is to use glue. And the stick glue, I don't like it, because it's really easy to remove the part from the bed, and it's really easy to apply. It's fantastic when it comes to removing from the glass because with just water it melts, it's soluble, so it will come off. But the final results which I managed to obtain were always a little rough, so I had to file them, I had to sand them, and some of the sanding paper can leave black marks. The final result is not worse than the one you already seen, but it's still not clean. So I've been dwelling for a while to find a solution for this one, and I haven't until a couple of days ago. A couple of days ago I was printing this case for a Bus Pirate 4, and I spent a lot of hours designing the case because I wanted it to be really, really snug. I wanted to add external buttons. And when I printed, the bottom came off rough, of course. There was stick glue at the bottom. So while the tops are pretty clean and neat, the bottom had that typical finish of when you apply stick glue to the print bed. And of course I have a lot of material in my lab, but I had never thought about it. So I found a piece of... Sorry, I had to go for a moment. I found a piece of acetate which I had it in my lab for a long time. I used this when I had to print with a laser printer, when I had to print transparent sheets to how is the word, to impress I don't know the word for that one, the copper clad to make PCBs, so I printed in black, and while I was opening the drawers I found this pack of sheets. And I thought, this thing goes in a laser printer, which means it gets pretty hot and it won't bend, it will not warp because of the heat. So it means that this can resist to quite an interesting temperature. And my idea was, okay, well, why don't I use stick glue to print this one to the glass build plate, and then the part can be printed on top of this one and come off really, really nicely, in my idea. But I had to test it, so I made some minor modifications to this case, and I set to do this, and I'm gonna show you how I do it. But first I'm gonna show you the final results. So I'm gonna cut for a second so I can find a better version of this one. I'm back. So this is the first version which I printed, and it did need a lot of filing, and well, you can see that sometimes when you file you can mess it up. But the final result was still very shabby. Consider these two parts, they're printed like this, bottom to top. But after I used this one, the bottom came off surprisingly well. It's shiny as much as it reflects, and you can see there is a dark line here, and that happened because this was my second print and I left a piece of hold filament extruded on the sheet. So when I washed the piece of acetate, I didn't clean it really well. You can see that some marks remain, but it can be definitely used a few times over and over if you clean it really well. You have to wash it, be delicate, and there are some kinks in this piece of acetate which I caused while I was washing it. So this one will not come off, and it will probably burn part of the filament for whatever reason. I haven't figured that out yet. But the final result is quite impressive. So I decided to keep printing using this technique and just, you know, disregard the whole mess of cleaning up the glue and having to file and sand and clean and file again and so on. I have set up a small tripod in front of my 3D printer and I have a model to print, so I will proceed with this one now. I know that the iPhone camera is possibly not the best way to film a screen, but I just wanted to show you part of the process before I head over to the 3D printer. I have a model which I made yesterday for a project I'm working on, and you know, it's very detailed and I want it to be looking very well once it's finished. So I will print it using, well, I will print it from Fusion 360. I will not use Cura, which is the stock slicer for the Ultimaker 2. I like to use Simplify 3D, which has an exceptional slicer, and it's a little more complicated to use, but I really enjoy using that one. I did not want to create another factory file for it because this one has been serving me really well, so I am going to add it to another factory file which I've been using the other day for something else. I'm exporting to STL from Fusion 360, which lets me import it in this one. So it's placed on the bed, and I really like Simplify 3D. I invite you to give it a shot. I don't think they have a trial. But okay, so I'm gonna check the process settings. Everything seems okay. I haven't touched it, so it's supposed to just be working. I'm going to, oops, this is not the right model. Yeah, this is what I need to do. I need to remove this and I need to select the proper model. There's a preview slicer which lets you see the path. Okay, well, I don't know what these two colors mean yet. It's oh, the speed. So this one is going to be printing slower. Alright, so we're ready to export this one to an SD card. At this point, all we need is a 3D printer with a glass build plate, some stick glue, whatever brand is the same, and some of this. Well, it's the transparent sheets which I was talking about. They're not cheap, as I said, but if you're careful, you can reuse them quite a few times. These particular ones come with some paper attached, just to keep them from sticking to one another. And I'm going to cut a piece to fit my build plate. Magic, that thing disappeared. Alright, let's prepare the build plate. The build plate has already been cleaned with water and it's been dried. So what I do, I apply my stick glue to this nicely. You don't really need a lot of it because it will kind of stay in place, but what you want to avoid is that your extruder nozzle ends up touching glue. It gets sticky really quickly, and this glue will possibly also burn. I don't know, I'm just making this up as I go. So there it is. I know that my part is centered on the build plate, and there it is. And you can use, I don't know, a squeegee or something. I like to use this one to make it really flat on the build plate without scratching it. I mean, you want to avoid leaving marks on the acetate which can, I don't know, cause defects, I mean very small defects on your print. So there it is. And what did I just do? I left a mark on the thing. I mean, this will be printed here. With Simplified 3D, the nozzle will come down here, will eject some of the material, and then it will drive here and diagonally reach the position where it will start making a brim around my print, and then it will start extruding. I will shoot a piece of video to also show you how the rigid ink filament behaves, to show you what I mean when I say that it really expands when it's extruded. The temperature is close to 210 degrees Celsius, which means the extruder is going to start spitting filament really soon. Okay, so I always do this. I clean the nozzle a little. You can see the material, and if you look carefully, you will see that it seems to inflate as it comes out. And it's a really good material. I will move the camera. So cleans the nozzle, and then it begins printing on top of the acetate, and it will stick perfectly. The acetate sheet will not move from the build plate, and it will offer a really smooth surface, which is really easy to remove when the print is done. We're back in front of the Ultimaker. I don't remember how much time has passed, but you know, we're at the moment of truth. We're at the time of removing the part from the print, from the build plate. Okay, so as you see, everything is very clean. The glue is underneath the acetate, and you know, usually you have to go with all your tools and try to remove your part without scratching the build plate. And now that I have this this acetate on top of it, the part is really well printed, except some very fine poles which I will have to refine. I think it has to do with the cooling down, fan speed or something like that. I will figure that out later. But the part is printed, and let's remove it really quickly. So this one will come off because it's sitting on the stick glue, and done. See, the glue is still a little bit sticky. It will dry out, but it can be washed out. And now to remove the part, I just have to do this, and it's off. It's shiny and reflective. There's a brim which I will file out in a minute, but the results are fantastic. You have a really flat and smooth bottom. There's a hole here which came out really well. There's no material sticking in places where it shouldn't. So I would call this a success. So here we are. I have removed the brim. Needs some more fine sanding, but we have what we're looking for, like a shiny, smooth bottom. So thank you very much for watching this video. I hope that this trick is helpful for some of you out there, I just want to, full disclaimer, I am not in any way connected to Rigid Ink or Ultimaker. I use their products because I think they're exceptional. The Rigid Ink, I bought two spools, and I plan on buying more, especially because one of the two still sealed ones is a beautiful blue filament that they have, and I plan on ordering more. So I don't really accept sponsorships. I like to pay for what I use. I just want to share part of my process, and I'm gonna try and do this more and more on this channel. Still, supported by rudimentary gear, because I don't have time to set up lights and everything. I have a couple lights. I don't know, just share the video, like it, and please put some comments. I want to post more content related to electronics, microcontrollers, 3D CAD design using Fusion 360, other 3D printing tips, and so on. So as the channel develops, I will find more topics, and I accept suggestions. Thank you very much for following. Cheers.